A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Sounds treacherous. What is the velocity of the top of the ladder when the base is given below? Boom, boom, boom. So we have 8, 16, 22, etc., etc., etc. Okay. So first thing to do is start by drawing a triangle. We already have a triangle drawn, but I will do it again, not to scale. And so we have a constant here, which is 25. We're told what is the velocity of the top of the ladder when the base has been below? 8. So we have 8 here. And then we know that it's moving 2 feet per second. And we're looking for the velocity at the top of the ladder. They give it as r. Okay, so first thing I'm going to do is find a relationship between everything here. So the way I'm going to do that is we know that x squared plus y squared equals hypotenuse squared. Rearranging that, we have y equals h squared minus x squared square rooted, which I will rewrite again one time. Well, okay, probably many times. H squared minus x squared to the 1/2. And the reason I do that is because it makes it more obvious how to do the derivative. So switching over to green, not really for any particular reason, just showing a change in train of thought. Take the derivative of both sides. Derivative of y with respect to t is dy dt. And that will be, we'll use the power rule here to get 1/2 h squared minus x squared to the negative 1/2. And then we do the chain rule as well, which gives us derivative of h squared. H is the hypotenuse, which is constant, 25. But x, which I'm going to call, if I didn't make it obvious, which I did not, this is going to be x, that's going to be y. We'll take the derivative of that, which will be negative 2x. Simplifying this a little bit, the 1/2 and the 2 cancel. And then the negative 1/2 can go on the bottom. So we have, I forgot, negative 2x dx dt. There we go, because you have to do the chain rule on the inside to get the 2x, and do the chain rule on the x to get the dx dt. We are left with x times dx dt all over, let's say, h squared minus x squared square rooted. I know it looks cumbersome, but probably not all that bad. Okay, so now looking at this, we don't know what this is. Oh, this will be dy dt over here. We don't know what this is, question mark. We know what x is, we know what dx dt is, we know what h is, and we know what x is because we know what x is up there. So x is, I think it was 8, and then dx dt, 2 feet per second, and then h is 25. So working with this, we have 8 times 2 all over 25 squared minus 8 squared quantity square rooted. Bum, bum, bum. Go to the calculator. On. Clear. I'm just going to call it 8 times 2 is 16. Nope, I'm going to do the bottom first. 25 squared minus 8 squared. Second square root. No. Second square root. Second answer. 16 divided by second answer. We get 0.676. 0.676. And this will be meters per second. So that gives us the answer of, did I forget a negative? I'm pretty sure I did. Whoop, that negative right there. Click, click, and clack. So dy dt, which equals r, at x equals 8, equals negative 0.676 meters per second. Okay. So now, I think they asked us for other distances, which should be easy because we just plug in the number. 16 feet away from the wall and 22. So 16 and 22. I'm going to rewrite those over here real quick. I know, not a lot of space. Extra messy. That's fine. Okay, so at 16 times 2 all over 25 squared minus 16 squared square rooted minus gives us calculator 25 squared minus 16 squared. Second square root, second answer. 32 divided by second answer gives us negative 1.66. Negative 1.66 meters per second. Makes sense that it's going quicker. And then the last one at 22 should be the quickest. Pretty close to 2 meters per second. Or would it be more? I don't know. We're going to find out. So then for 22, we have 22 feet per second times 2 all over 25 squared minus 22 squared. Square root the quantity. Don't forget the negative. Make that an equal sign. Go to the calculator. 25 squared minus 22 squared. Second square root, second answer. 44. Whoa, that went way off the rails. Don't forget the negative. 3.7. Negative 3.7 meters per second. Okay. So that is the way we do. I should probably write those in real quick. 3.7. Negative. They might not actually want the negative in there. 1.66. 1.66. I'm going to get rid of that negative. And I'll show you why in a second. Coming back, 0.67. Let's say 0.68. 0.68 feet per second. And the reason is because they have the R pointing down. And so I had my axis where positive Y is higher, but they sort of have the positive axis going down. So if you want to do it in the same way, it's probably not a negative answer. They're asking how fast is it falling, and the answer I gave was how fast it was rising, which is a negative number. Okay, I'm going to get rid of some of this because we now know it. Okay. Consider the triangle. Bum, bum, bum. I do love triangles. Consider the triangle formed by the side of the house, ladder, and the ground. Okay. Find the rate at which the area of the triangle is changing when the base is 8 feet from the wall. Okay. So I'm going to start by writing out the formula for a triangle. So area of a triangle with respect to t, a t is for time, not triangle, is 1/2 base times height. And in this case, our base is going to be x and our height will be y. So we take the derivative of both sides. So we have derivative of area of the triangle with respect to t over t equals 1/2. Now this is going to be the product rule. So uv prime equals uv prime, or u prime v plus uv prime. I know, it's completely sideways. U equals x. Nope. V equals y. U prime equals dx dt. V prime equals dy dt. So we just plug this in. Go to the green. So we have u prime. So we'll have dx dt times y plus d. Nope, I was going to call that x times dy dt. Okay? We know that dx dt is how fast it's moving outward. So I'm going to say that dx dt, this right here is 2, that'll be feet per second. Y, that's how big the house is at that time. And we can find that using Pythagorean's theorem. So we do, actually I'm going to solve this one first. We know that's 8 feet. And this was an answer that we got previously, which was 0.68. But I'm rounding a little bit, so this is going to be a little bit off. And I'm going to call that negative 0.68 feet per second. And wait a sec. So y then will be y squared equals h squared minus x squared, square rooted, cancel, equals 25. 25 squared minus 8 squared, which is, probably like 23. Maybe 24. 22. 25 squared minus 8 squared. Second square root, second answer. 23.68. 23.69. Okay, so now we have everything we need to solve this problem. So we have change colors to show my train of thought, my evolution of thinking. So 1/2 times 2, and this should actually be a, there we go. Yes, I'm fine with this. 1/2 times 2 times y, which is 23.69, plus x, which is 8, times 0.68, and then there's a negative involved. Okay, see if I can put that in the calculator without disaster and tragedy. So times 2 minus 8 times 0.68. Nope. Answer divided by 2, because that's the same as multiplying by 1/2. We get 20.97 equals 20.97, and this will be feet squared. Squared feet per second. There we go. 20.97. 20.97. And the key to this part was just you write out the equation of the triangle right here, 1/2 base times height. Then you take the derivative of both sides. Then you have to remember to do the product rule, and then you just leave dy dt and dx dt as such. Okay. Bum bum bum. I'm going to erase this because now that's cemented in our memory, our knowledge base. Find the rate at which the angle between the ladder and the wall of the house is changing. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 8 feet from the wall. Okay, so good, they gave us 8 feet again. Convenient. Angle, which the angle between the ladder and the wall of the house. Ladder, wall, so this angle right there. Okay. So we have triangle, like so. Theta. Okay, so we know SOHCAHTOA. We have, I'm going to try and use sine of theta. I don't think it matters, but I'm going to try and use sine of theta. So sine of theta equals, so opposite over hypotenuse, which in this case we have as x over h. Yep. And so that's the angle that we want? Okay, maybe. Find the rate at which the angle between the wall is changing. So we want d theta dt. So we have this equation right here. And we want to take the derivative of both sides. Not enough contrast between blue and purple. Light blue, okay. So what we're going to do then is take the derivative of this, which will be derivative of sine of theta is cosine theta, but then we need to do the chain rule, take the derivative of the interior, which is d theta dt, equals, h is a constant, so we're going to leave that, times dx dt, which we do know, because this is at 8 feet. Okay? Okay. But now it was like, well, what's this cosine of theta? Well, we know that cosine of theta, based on this, cosine of theta equals adjacent over hypotenuse. So adjacent over hypotenuse. Adjacent in this case will be y, hypotenuse will be h. I think that's right. So we can replace this as y over h d theta dt equals 1 over h dx dt. Okay? And so then d theta dt equals, h's cancel, 1 over y times dx dt. Is that true? Maybe that's true. So we know that y, oh, did I erase it? I erased it. Darn it. So we know what y is at, wait a sec, it might be on my calculator. 23.68. So y equals 23.68 when x equals 8. So we have dx dt, which is 2 divided by 23.68. And that gives us 2 divided by 23.685, maybe 0.0844, 0.0844, and this will be radians per second. And get a better 4 there, radians per second. If we convert that to degrees real quick, times 180 divided by 3.1415. I just don't have an intuitive feel for radian, so about 5 degrees per second. Maybe, seems plausible. So 0.0844, 0.0844. Oh, make that a better 4 radians per second. So to backtrack, the way we did this last part was we used the SOHCAHTOA identities. We just wrote out what we're looking for. So we had this angle up here. We defined that angle in terms of sine of theta. Probably could have used cosine as well. And from there, we just took the derivative of both sides, remembering to do the chain rule. Because theta, this right here, even though I wrote cosine of theta, this is actually cosine of theta of t. So that is a function in and of itself. Did the chain rule, we got a cosine theta, which is okay. Was I supposed to have a negative there? Maybe. I'm not sure. Okay. So we took the derivative, worked through the numbers, and eventually we came to an answer. So I hope that kind of thought process worked. General rule for these sort of things. First thing you do is you draw a picture. After that, you write a formula representing your picture. You find out what you want to find, which related rate, take the derivative of both sides, and just kind of work your way through it. So a lot of product rule, a lot of chain rule, but these are good problems overall. Hope that helped. See you next time.